Buildpacks turn application source code into production-ready container images without requiring every team to maintain a Dockerfile. You do not need to install the runtime, compile the application beforehand, or configure the build environment. Buildpacks handle that work. They detect what kind of application you have and what it requires to build and run. Then they execute the build and containerization using the required components. But how do they do that? Well, Buildpacks are not just one universal magical tool. It is a set of software solutions. First, there's Buildpack. A Buildpack recognizes and gathers everything your application needs to build and run. Then there's a builder. A builder packages Buildpacks, lifecycle tooling, and the build and run image configuration. Its build image provides the build environment. Its run image provides the environment for the application at runtime. Also, there's a Buildpacks platform. It executes the lifecycle. It supplies source code, a Buildpack or a builder, cache, registry credentials, environmental variables. One example of the Buildpacks platform is the Pack CLI. Finally, there's the lifecycle. It coordinates the build and exports an OCI image. The lifecycle executes the build in 5 stages. 1. Analyze. It checks for the earlier version of the target image, reads its metadata, and verifies that it can publish the new image to the registry. 2. Detect. It tests the group of Buildpacks against the source code and selects the first group that fits. That group defines what is needed to build the image. 3. Restore. It restores reusable layers from the previous image and cache, so unchanged dependencies and artifacts do not need to be downloaded or rebuilt. 4. Build. The selected Buildpacks run in order and create layers for the runtime, the dependencies, compiled application, environment configuration, launch processes, and SBOM data. 5. Export. The lifecycle assembles the final OCI image from the run image and launch layers. It sets the entry point, writes the metadata, saves reusable layers to the cache. Cache-only layers stay out of the runtime image. So, why use Buildpacks instead of Dockerfiles? Well, apart from the obvious convenience. You see, with Dockerfiles, developers define the whole process. They choose the base images, install dependencies, define the entry point, define the startup commands, and ideally, optimize for security and performance. Well, for developers, it means they need to have the Docker expertise. For platform teams, that becomes a maintainability problem. They may need to update dozens of Docker files, each written differently, test them all, and ask teams to merge the changes. Standards are also harder to enforce. On the contrary, Buildpacks move common container building logic into reusable, language-aware components. These components are managed centrally. Developers provide application code and configuration. Buildpacks create production-ready container images with best practices for security and efficiency already in place. And that provides several benefits. Well, first, developer productivity. A developer can easily package the application without becoming an expert in Dockerfiles, Dockerfile syntax, layer ordering, base image selection, or multi-stage builds. Second, consistency. Buildpacks apply the same defaults for supported applications. Runtime installation, dependency resolution, launch configuration, image layering, and, depending on the builder, non-root execution. Third, caching and faster rebuilds. Buildpacks split an image into layers for the runtime, dependencies, and application code. When the application changes, dependencies can often come from cache instead of being downloaded again and rebuilt. Fourth, centralized and fast runtime updates. When the runtime receives an update, such as an OS security patch, for example, you can replace those base layers without rebuilding the application or downloading dependencies again. This process is called rebasing. Buildpacks also generate SBOMs by default. This makes it easier to see what ended up in an image and use this data for scanning, audits, and incident response. Well, of course, my point is not to paint Dockerfiles black or deem them obsolete. It's just that Buildpacks and Dockerfiles are two approaches to building container images. Dockerfiles give you fine-grained control over the build process and ultimate customization. They can be more suitable for custom, legacy, or unusual workloads. On the other hand, Buildpacks give you standardization across services. This standardization is harder to reach and maintain manually, but in turn, they take away some customization. But of course, you can create your own Buildpack. But of course, without digging into the intricacies of building your own Buildpack, Buildpacks may be more suitable for more conventional workloads, for supported languages and frameworks. Getting started with Buildpacks is really easy. In this video, I will use Paketo Buildpacks as an example. It is an open-source project that implements the Cloud Native Buildpacks specifications and supports the most popular languages. Okay, so you need the Pack CLI, Docker or Docker-compatible daemon, and a functioning application, of course. Then you can build the image with Pack build. The path option points to the source directory. The builder option specifies the selected builder. You can inspect the builder locally to see its included buildpacks, lifecycle version, build image, and run image. You can use one of the standard builders based on Ubuntu or the BellSoft's builder based on minimalistic Alpaquita Linux with Muscle and glibc variants. You can also set the default builder. In this case, the future builds need only the image name and the path to the source. You can also use the Pack CLI to retrieve the SBOM for a specified image. The core idea is that Buildpacks turn the source code into the production-ready container images without needing a Dockerfile for every application. As such, they remove the repeated container work and give platform teams a more consistent, maintainable, and secure build path. For a more detailed explanation on the Buildpacks, including the examples for using Buildpacks with Java, Python, Go, and Node.js, see the article linked in the description. And also, don't forget to like this video, subscribe to our channel, and until next time!